Hey everybody, it's Wojo. Today we're going to talk about reasons that we have to reverse an inequality symbol that pop up when we're solving algebraic equations. There's going to be two reasons that we're going to have to reverse an inequality. And when I say reverse, what I mean is take a less than and change it to a greater than, or change a greater than into a less than. But sometimes we have to reverse an inequality for the statement to remain true. One of the things we learn when we're solving is if I want to subtract 5 from one side of the equation, I have to subtract 5 from the other. Otherwise, that equal sign is no longer valid. It's not equal. There's some things that happen in inequalities as well. And one of the reasons we're going to have to reverse that sign is if we want to flip-flop positions. So if I have a statement, for example, if I have a statement that says something like 3 is greater than x. So 3 is bigger than the numbers that I'm thinking about. And I want to flip-flop. I want to move the x into the first spot and the 3 into the second spot. So I just want to change their spots. I have to reverse this inequality for it to be true. So if I said, for example, 3 is greater than 2, I think you guys would all agree with that. But if I instead didn't want to talk about how does 3 compare to 2, I want to compare how does 2 compare to 3. So I want to flip-flop these positions. I want to just take them and switch their order. If 3 is greater than 2, I can't say 2 is also greater than 3. I have to reverse that inequality. So it goes from greater than, pointing to the right, to less than, pointing to the left. So that's what I mean when I say we have to flip-flop positions. We have to reverse the inequality. If 3 is bigger than the numbers I'm thinking of, then the numbers I'm thinking of have to be smaller than 3. We use this quite a bit when we just talk in English. If I said, I am older than you, and I say my name first, I am older than you, I can't turn around and then say, you are older than me. If I switch it and put your name first, I'd have to say that you are younger than me. So if I'm older than you, then you're younger than me. We have to reverse that so the meaning stays the same. So if we're ever solving and x comes second, we want x to come first, we can do that. We can flip-flop the positions, but we have to remember to reverse the inequality symbol. So that's one of the things we got to think about. But there's another example we got to look at when we have to reverse an inequality. And that's when we're solving if we multiply or divide both sides of an inequality by a negative number. If we multiply or divide both sides by a negative number, we have to flip. And the reason we have to reverse it has to do with numbers like 100, I'll call that a big number, are bigger than small numbers like 1 in the positive scale. 100 is greater than 1 when we're talking about positive numbers. But if I talk about negative numbers, negative 100 is much smaller than negative 1. So negative numbers, something like negative 100, is smaller. So if I switch from the positive world to the negative world, I have to reverse that inequality. And one of the ways that it's really easy to switch is if I was doing math and I divided both sides by negative 1, which I should be able to do because I did it to both sides. If I divide both sides by negative 1, then I would get negative 100 and negative 1. If I didn't reverse this sign, if I didn't change this from a less than to a greater than, then it would no longer be a true statement. So whenever I multiply or divide both sides by a negative, I have to reverse this sign. I have to, whoops, I didn't even reverse it there. I have to switch that symbol from greater than to less than. That is a mess. I'm just going to start over. Negative 100 would be less than negative 1. If I didn't reverse it, then I would be giving myself a false statement. And so let me show you in an algebra problem what we have to think about when we're solving that. And then I'm going to have you guys try a few of them on your own to see if you'll remember to reverse the inequality sign. So give me just a second. I'll have some problems up and then we'll get started. Alright, so let's just solve this problem for x. So we still want to get x by itself. We'll still start farthest away and we'll continue our work. So on this step, I'm going to subtract 4 from both sides. Now, one of the things I want you to know is in subtraction, in addition, the inequality isn't going to change. And so you're just going to carry that greater than symbol down. So the 4's cancel out, the negative 2 comes down. The greater symbol does not need to reverse. We only reverse it in two situations, when we flip-flop positions and when we multiply or divide both sides by negative. If we're not doing either of those, then that symbol can stay. We could just bring it down and treat it just like it was an equal sign. But as we're solving, if we divide by negatives, then we're going to have to reverse it. And so often you'll do a problem, you'll say, okay, I need to get rid of a times -2, so I'll divide by -2. It's at this stage, when I divided by a negative, then I'm going to have to reverse the sign, divided by a negative number. I divided both sides by a -2. So I would go through and do the math. X there, 8 divided by -2 is -4. But at this stage here, when I did that, this was a true statement here, but after I divided by a negative, if I want to keep it true, notice what I have to do with that symbol. It is pointing as a greater than symbol, it's pointing to the right. I have to reverse it and point it to the left. If I forget to do this, then I'm going to give the whole range of numbers that are wrong. I'm going to give a bunch of numbers that don't work. The only way this is going to work is if I pick an x value that's less than -4, and I had to switch it. Some students don't even notice that I did. Look at which way this arrow is pointing. It's pointing to the right. If I drew this as, an arrow, it points to the right. Now the arrow is pointing to the left. It's the less than symbol. We have to do that reversal or else it's not true. So we say any number that's less than -4. So if we thought of a number line, if -4 was here, then -3 would be here, -2 would be here, and smaller numbers like -5 and -6 would be here. We would graph our solution with an open circle because it's not equal to -4, and then we would just highlight all the numbers to the left of -4. And so one of the answers could be numbers like -5 or -6. So if I plug -5 into this equation, it should work. If I plug in -5, -2 times -5 plus 4 should be greater than 12. Well, -2 times -5 is 10. 10 plus 4 is indeed greater than 12. So that works because it makes a true statement. 10 plus 4 is 14. If I didn't reverse that symbol, it would have said that didn't work. It would have been 10 plus 4, or I'm sorry, it would have still said that, but I would have said x had to been greater than -4. I could have picked like a number like 0 then, and 0 plus 4 is not greater than 12. So it would have gave me some wrong solutions. So it's really, really important that when you divide by a negative, you switch the sign. Now what I want to do is I want to do the first example of the practice problems I gave you, so you have at least one of those problems done. And so the second problem that we're going to look at actually has both the switches in it, because sometimes you're going to have to use both of those rules. You're going to have to flip it because it's flip-flop positions and because you divide by a negative. So this is the first problem that I asked you guys to solve today. It says -36 is less than or equal to -3x minus 3. If we solve that, it's going to start solving just like normal. We're going to start by farthest away from the x. We're going to undo everything. Notice what we're doing. We just added 3. Adding 3 works just fine. We can keep the inequality symbol the same. It's pointing to the left. It's still pointing to the left. It's the less than symbol because all we did is we added on this. Adding and subtracting doesn't mess with the inequality symbol. But when we go to solve this next step, to get x by itself, I have to divide by a negative. And again, anytime I multiply or divide both sides by a negative, which I just did, I divided by a negative, I have to reverse that symbol. -33 divided by -3 is 11. These cancel out, gives me the x. But which way should my inequality face now? Since I divided by a -3, I'm going to have to switch this from a less than to a greater than. And the equal sign stays. So if it's less than or equal, it just switches to greater than or equal. Now oftentimes, this is the right answer. It says 11 is greater than or equal to my x. But sometimes I like to have x first. So if I want to put x first, instead of having it second, if 11 is greater than x, then I have to flip this and say x is less than or equal to 11. And so there are sometimes I have to flip it once. So I flip my sign here. I did a reverse of my sign. I flip-flopped positions, and I had to reverse the sign. I divided by a negative and had to reverse the sign. So I had to reverse it 2 separate times. One from dividing by the negative and one from the flip-flopping of positions. anytime we do either of those actions, we're going to have to reverse that symbol. And so that's the big idea today, is when do we reverse it? We reverse it when we divide by a negative. If you guys have questions over that, we'll definitely talk about them next time in class. As you're working, just try to remember that if I divide both sides by a negative, I'm going to reverse that symbol. So the less than turns to a greater than. If I have to flip-flop my positions to put x first, instead of having the number first, then I'm going to have to reverse that symbol. So sometimes it flips once, sometimes it flips twice, sometimes it doesn't reverse at all. I shouldn't say flip all the time. It's reversing the sign. It's changing it from less than to greater than. I hope it made some sense to you. We'll definitely talk more about it in class. It is something we work on the whole rest of this unit. I just wanted to get you guys an introduction, so we'll talk to you guys soon.